Howdy, we're the Housing Block Design team from Texas A&M University, proud to be speaking with you about our product from the 2020 SME Direct Digital Manufacturing Competition. Our team members are James Jershevsky, Spencer Dempsey, Nicholas Stockton, and our advisor, Dr. Wayne Hung. I'm Spencer, and I'll be your presenter today. So our mission for this project was to use additive manufacturing to create a product for natural disaster relief. Key factors from the competition criteria that we kept in mind during this project was to make sure our product was cost effective, make it easy to use with no machinery required to build it, and to make sure it remains sustainable. We found inspiration when looking at seismic areas such as the Andes Mountains. We found that Incan civilizations had built walls with stones that were interlocking and stayed in place without mortar. This allowed them to withstand earthquakes because they could move during a quake without compromising the structural integrity of the wall. So here's the design that we created. It is a block that can be used to build houses, walls, or any unique structure. You can see the model here on the left. It's made out of a rubber silicone composite. The crumb rubber in this composite coming from recycled tires answers to the call for sustainability. The tire rubber being a thermoset can prove sometimes hard to recycle, so this product provides an easy path of recycling for those old tires. And due to the abundance of the material cost can remain low. And you can see now with the image on the right how additive manufacturing practices were applied. The internal supports here reduce the weight while increasing their strength, and this can eventually reduce the shipping costs as well. So our structure needs to withstand the environment it's placed in, and the material properties actually from the recycled tire rubber give our design good UV resistance so that it doesn't degrade in the sunlight, as well as water resistance for when it rains. So this is what a wall made out of blocks would look like. It's color-coded here to show the individual blocks, and they don't need mortar in order to stay in place, and you can see the interlocking function there. An inexperienced person can effectively stack them, making a wall and then a house. So this means people displaced in a natural disaster will be able to build their own house, empowering them after a traumatizing event. And since they can also move and wiggle a little bit, they can also withstand minor earthquakes, similar to the Incan design. These blocks, however, they're not possible with traditional manufacturing. The system that we had come up with is a binder jetting system with a Dr. Blade setup that will spread a layer of the crumb rubber over a large build platform, and then a silicone binder will be sprayed onto the layer. You can see here. This process will repeat until the parts are finished, and then the build platform can be wheeled into an oven where the silicone binder will cure and solidify. And unlike most binder jetting processes where there's a debinding step and the binder is burned off, our binder is integral in forming the matrix of our composite. And because of this, we don't anticipate any shrinkage during the curing process. Once it cools, the blocks can be taken out, and then the unused crumb rubber can be recycled back into the beginning of the process. The amount of blocks made at each time is reliant on the size of the build platform. So, with a large enough platform, you could even hold over or up to 100 blocks. So here's what a basic house design would look like. We stacked every block in Fusion 360 to show that it was even possible. And you can see, though, the door is a little narrow and there aren't any windows. So moving forward, especially as this whole concept is just kind of in its starting phase, moving forward, we want to do certain improvements like having a construction manual, different floor plans, and even adding a foundation, making it easier to assemble with the corners, which are kind of tricky with the pattern currently, as well as adding more solid windows and door openings, and making sure that its cost is feasible throughout the entire development. So in conclusion, this product will help bring relief to disaster areas, giving communities their homes back. It can help mitigate damage from the future, earthquakes, and help prolong the life cycle of tires, keeping them out of landfills. So we just want to end to say thank you to those listening. From our team, we want to thank SME and the judging panel. We learned a lot during this competition.